Alrighty. Zero array transformation part 3. Guess we already did the first two. You're given an inter-array nums of length n and a 2D array queries. Okay. Each query has a left and right index where you can decrement value each index in nums at most once. The amount by which the value is decremented can be chosen independently for each index. The amount by which the value is decremented can be chosen independently for each index. Okay. Decrement the value each. Okay. Zero arrays, if all elements are zero, return the maximum number of elements that can be removed from queries such that the nums can still be converted to a zero array. Using the remaining queries if not possible to convert nums to zero array, return -1. I see. So you want to have a minimal set of queries to zeroed out. So here you could probably remove the 1, 1 because the first two can cover removing the 2's there. So the number of removals is 1. And if it's not possible, that's -1. Okay. So here you can do 1 to 3 and 0, 2, so you can at least remove 2. And I don't think you can remove more than 2, so yeah. And then here you can only move 0 to 3, but then these things will get zeroed out, so not possible. Alright, understood. Let's say n is the number of queries. Actually, n is the length of the nums, and q is the length of the queries. Alright, so how to go about this? If I were to use the last thing I did for this, which was like creating an array of total changes. Creating an array of total changes at any given index. Could I modify that somehow to retrieve information about the number of queries? So let's see. 202. I ordered the queries. And I applied the queries. So if you remove a query, well, actually, what is the space of the number of queries here? It's 10 to the 5th queries. 10 to the 5th means you probably can't do n squared stuff. You can do n log n speed stuff. Yeah. Well, it's either linear or n log n speed. No, it might be n squared. So if I were to, so let's take the simple example of 202, and so this is example 1. And the queries are 0 to 1, 1. So if I know that my max decrement array is going to be like +2, 0, no, plus 2, plus 1, 0, and then minus 3, right? So I can remove at most 2 things starting at 1, and then another additional one at index 1. So that's total 3 by index 1, total 3 by index 2, and then back down to 0, removal by the last, by whatever comes after nums at 2, which is nothing, which is the total decrement is 2, well, decrement, increment, whatever, 2, then 3, then 3, 2, 2, 3, 0, no, 3, 0. Could I somehow use the information to actually go back? So, so at any given index, there's going to be some excess removal, and the excess removal will be queries that you could possibly remove, not guarantee remove. And you can maybe go backwards and see which queries applied to the indices that had excess removals and see if you could remove those queries. Doesn't seem like it's optimal, but it's a starting point, I think. So yeah, so let's go ahead and say that I could also start with the trivial case, which is to see if it's possible. Okay, so let's say decrement, and this is still the same as the other one where the max length is the max length. Okay, so decrement change is going to be an array of length n plus 1, and for each start and end in queries, the dec change at the start is going to be increasing the dec change at the end. Decrement change at the end is going to be decreased, or n plus 1 is going to be decreased. And then I'm going to go the total change, or the total decrement is going to be 0 times n plus 4, n, 0 times n, 0 times n for each index in range of n. Actually, I'll probably just use append here. I guess I can't. Maybe I can't use append. Decrement change is going to start with the initial decrement change, or the total decrement change is going to be initially that. If I go for every later index, if I go for every later index, then total decrement appends the value at the index change plus the last value in the total decrement. Alright, and let's see if that still works. Like, I think it should at least total decrement. Okay, so decrement change is 2, 1. Okay, yeah, 1, 1. Okay, negative 1, negative 2. Total decrement change is going to be 2, 3, 2. Yeah, the total decrement is going to be the total number increase or decrease that you can apply to zero things out. Yeah, that's fine. And it's going to be 0, 2, so you can decrement the first one by 1, second one by 4, the third one by 4, and the last one by 2. Okay, so that seems fine. So next up is to figure out so I'm going to do the just simple case where it's not possible. So for each index in range n, if the nums at this index is bigger than the total decrement that can be applied at this index, return -1. Okay, so this should work for the impossible case. Yeah, okay. And then, so now that we've gotten to this point in the code, we know that it's possible, and now it's to figure out the number of queries you can remove. So again, I can go to every spot that has an excess number of decrement over the num value. And for each one, there must be, for each instance, there could possibly be queries that you can remove. And you want to remove it, be optimal in how you remove it. Like you want to kind of remove queries that maybe only have range 1. So then you have other queries that can do other removals elsewhere. That's not simple. So let's go ahead and do a small printout here. So excess decrement is going to be an array. Which index in range n excess decrement will add how much excess? Capping it, or so it's going to be the total decrement minus a value, and it always has to be, and this is always going to be guaranteed to be positive or 0. Can't be negative, otherwise it's going to be impossible. Okay, so let's go ahead and just print out what this looks like. Okay, so 0, 3, 0 means that at the index, the second spot, there was 3 decrement if there was a 0 value, so there's 3 possible queries that could be removed, and this would still work. here it's 331. Okay. So yeah, 331. Where's we didn't reach that stage. Okay. So how to optimize which queries? So if a query covers something that an index that has no access, then you can't really maybe remove that from the possible queries to remove. So for instance, if 02 query 02 covers indices that have 0 access, so I know that I cannot remove query 02. That's one way to remove it. Still seems kind of complicated because it's pos. Is it all that complicated? So I go through all my indices. If I see a 0, I remove any queries that apply to that spot. Would my remaining set actually be minimal set? I just do that. So if I remove everything that had 0 index, yeah, that doesn't quite work right. Like if I just remove 02, I technically am left with 131312, and that's not the minimum set. So what's happening on this one? 1313 12. Okay. So when I remove anything that is absolutely required, I need to make the excess of the remaining spots for it to be less, because it's no longer like free, kind of. So if I remove 02 because I realize that that's required, this thing becomes 22. Alright, this thing becomes 22. This still doesn't solve it. So I guess the other thing is in this spot, the 2 1-3s, one of them has to work. 2 1-3s, one of them has to be there. So I can't. How do I detect that? Even if I could detect that, like how would I know which? I mean, this could be like a 1-3, and this could be like a, I don't know, a 1-10. And you kind of really don't know how you distinguish which one you should be keeping, which one should be removing. Okay, so I think that's, so let's go. I have example 3. So if I start by assuming that the 02 is guaranteed because the 0 is in that spot in the index of the excess. So it becomes, so the query no longer is, the query becomes just 131312, and you're left with an array that's like 0, 0, 0, 1. Yeah, you're left with an array that's 0, 0, 0, 1, and your queries are now 131312. And your access is now your access is now 2. Actually, your access is still 3, right? Yeah, you don't subtract. Yeah, I was mistaken there. Your access is still gonna be 0, 3, 3, 1. Is that right? Yeah, your access is still that much. So in theory, you can remove 3. In practice, you can remove 2. The 1 here means what? You have 1 access there, but you could have you have at minimum 1 access. You have at maximum 1 access. I think you might have at maximum 1 access. What does that mean? So could maybe start removing. If I start actually applying the remove process, somehow prioritizing maybe the minimum length queries to try remove, in which case you can remove the 1, 2. If you remove the 1, 2, the excess becomes 0, 2, 2, 1, and then you try to remove the 1, 3, and the excess becomes 1, 1, 0. Again, it doesn't seem like it would always work. Sometimes maybe the longer one needs to be removed first rather than the shorter one. Or the longer one leads to more accurate stuff. Okay. Okay. So you remove the queries that are mandatory. So the queries are 2 in length. How would I even know and which queries are applied at which indices. Like I would need to keep track of a list of queries for every indices, where that list of queries is the queries that are applied at that index. Eeks. Huh. Okay, so let's see if I can't make that. So needed queries. Let's say required queries. Try to find something that's let's say required. I guess it'll be a set or list. It'll probably be a set. I go through all the indices and and keep track of which one is current at that index, currently decrementing at the index, then when I see a 0, I would be adding sets with sets, or adding a list to a set. Adding a list to a set seems pretty bad if I do that for every index. Seems really bad. It would require like comparisons of Q queries with, or adding basically Q queries to a set each time. And that's for, yeah, that's just too slow, I think. Too much computation. Is there a faster way of determining it? I guess if it doesn't work, then it just derails this whole train of thought. So if the number of queries is finding the minimal set to remove. So what if I had what if I made a pass and was keeping track of the current access, and the current queries that are being applied. And then whenever I detect that there is excess, then the first query that drops off is counted as the first removal. So any query that I remove must be in a strictly excess period of my array. So for instance, 1 2, that's in a portion of the excess array. One, 2 is in a portion of the excess array. And you cannot remove anything that is in the non-excess portion. So, and maybe it's the case that so 0, 2 is in the non-excess portion. And if I remove 0, 2 as possible, if I remove 0, 2 from my queries, does my access fee go down? Shouldn't, right? It shouldn't because it's the first one. So if I had 2 0, 2s, then the second 0, 2 should actually remove the excess. Maybe I should be keeping track of what is so excess is total decrement minus the nums at that value. It's the number of spares. Okay. I think I have an idea. It's kind of fuzzy. Guess I should probably flesh it out in terms of an example before I try to code it. Always try to make sure I know what I'm coding or know what I expect to get from my code before I blindly code things. So what am I thinking of? Thinking of sorting the queries. That's almost necessary. I guess right here is when I start needing to sort it. And so if my queries is sorted, then as I pass through the indices, see which queries are currently applied at this index. I see which indices are currently applied at this index. So at index 0, query 0 is being applied. And if I see that there's no excess at this spot, then I will add the current queries. Oof. I need a pass that just does the required queries remove. I think I need to do a pass where I just remove the required queries from my arrays so that I look at just the excess queries. So how do I do that pass? All queries that are currently in play at any time when I see a 0 on the excess. Doesn't seem clear. It's a lot of queries that could possibly be there. But I could make a list of all the spots where we have zeros. And then go through the queries that I need to go through in reverse. If I go through all the queries, see if they encompass a spot that has a 0. See if they encompass a spot that has a 0. And then I know that they're necessary. How do I do that so that's not n squared? I make a list of where the zeros are. Make a list of where the zeros are. And then I go through so the 0 got 0. And if I go through my queries, adding on to it, how do I pass through my queries? So use Q pop queries. So if I use a Q, pop queries on view of this stuff. I have a list of where the zeros are. Okay, so let's say I have zeros for my excess at indices, let's say randomly 3, 11, 20, 34, and 50. So how do I know which queries in the query list are covering those spots such that I know that I need to have those queries? So let's say the queries were like 1, 5, 2, 10, 11, 13, 11, 20, 13, 17, 18, 19, and 34, 51, 50, 50. Okay, so how do I know which one are necessary? So I see that my first axis is at 3, and I can tell so while how are queries even in the array? Okay, so parse through my queries, and while the start of the query is before the current 0 index, 0 axis index, and the end of the query is after it, then it is going to be required. So this thing's required, this thing's required, and then here the start is not. So, and because, so I would parse through every queries whose index is, I parse through every index whose query start is before the current removal. Doesn't seem like it would always work, because parse through everything whose start is before things removal. So I have to parse through this thing, have to parse through this thing. If the start is before it, then it needs to be, it has to be looked at. Does it have to be dropped if it doesn't work? I think so. But what if it was like some of this? Like this is 2 to 15. So if I skip over, or this is like 1 to 50. If it's 1 to 50, then it would automatically work. It would automatically be treated as something that is required. Okay. So yeah, if the start is before the current removed index, then you need to evaluate it, because every later index that needs to be removed will have a easier constraint on whether or not you can remove it. So you should be able to evaluate any query as being necessary if the starting index is before the current removed index. So I can detect that this thing's required and this thing's required. and then I get to 11, and then I go down the indices until I see a start that is equal to or before 11, and I say that this thing's required, this thing's required, and this thing is whatever, and then I move down here, and 20, and here the start and end is before this, so I can say this is not required, not required, this thing is required, and then I get to 34, so I go down here. Okay, so I think that could play. So I sort my queries, and then for every query, for every index in the range of my axis indices, where the axis indices is also n, access is equal to access decrement at this index. If the axis is equal to 0, then I need to have a Q index. So do I need a separate data structure for this stuff? Can I do it in using the current stuff? So detecting the zeros at these indices, I can do a pass for that, right? Every time I see a 0, every time I see a 0. Okay. Every time I see a 0, then I work on my query index. So while the, actually let's say, while the Q index is less than n, and the queries at the Q index, the start of it is less than this index, less than or equal to this index, then I should be able to evaluate whether or not it's an excess. So required is here. And required is going to be the indices of queries that apply to spots with no excess. So it must be in minimal sets. And any minimal set of queries. So while the Q index is less than n, queries. So yeah, okay, so if the queries at this Q index ends greater than or equal to the ending of it is greater than or equal to the current index. starts before, ends after, or currently. Then required is adding this query index. And I think I will increment the query index at that point. Each time I should be able to process. Well, what if I don't increment if it's a query that goes, so 3, I go increment, and here, because the start here is not less than index I'm looking at. Don't evaluate it. Okay, and I'll say print the required. Okay, I think we need more labeling here. Required query indices and index change. And total change and the access etch. So 02 required, and that's correct. Maybe I should print out the sorted queries, because that's what it's actually referring to. For the required indices. Alright, so 0, 2, 1, 2, 1, 3, 1, 3, 0, 2 is required. Okay, so that's fine. So now, if I were to remove from consideration the required queries, what would that mean? So it doesn't change the excess. It doesn't change the excess. But everything that's left over is in some floating set of excess. Everything that's left in is in some floating set of excess. In theory, is there a minimal amount of removal I can do? Okay, so what am I visualizing here? So like the 3, 3, 1, once I remove 0, 2, is it still floating 3, 3, 1? If I just do 0, 2, 1 can still have, yeah, 3 can still have 3, so odd. I have this visualization in my head that removing certain queries that are necessary needs to somehow affect the indices that are that covers it. It doesn't. Sphere 2 is excess. Guess I just need to get rid of this idea. Okay, so really it's 1 3 1 3 1 2. I really don't need to change anything. So how do I know what I can get rid here? So if I remove 1 3, why would I remove 1 3? So if I start by keep track of at any given index, okay, so going back to this thing, so I figured out which are the required, so that's now no longer considered. It is still going to be 0331, queries is 131312. So sorted, it's 121313. So at any given moment, the sum, technically, it's kind of odd. The value decrement based on these queries is like 0332. Total decrement based on those remaining queries is that. So total decrement is that. Could maybe say that for any query that starts and ends in the total decrement in the spot, so they all have to start in they all have to start in excess and end in excess. They all have to be in excess. Can't be in zeros. So if I remove every query, if I remove the earliest ending query, does that work? I feel like that might. Every query starts in excess, and the one that ends the earliest gets removed. Yeah. And when you remove it, then what happens? If you remove it, then in theory, the stuff your excess goes down by that amount. But does that matter? Does that matter? So if you do 0, 3, 3, 2, like at index 1, you're starting 3 queries, or you have 3 queries in excess. And then at index 2, you see that 1 query is done. You see that 1 query is done, and you still have access. So you say that you're saying that so you say that query 1, 2 was access, pure access. And if you move that query, it technically becomes 0, 2, 2, 2, 2, 2, 2. And then what? Oh, that's not that total access. Access in that case, if you remove 1, 2, is going to be 0, 2, 2, 1. Okay. And then what? And then you see that you see a spot where the access is 1, 3, and your queries are 1, 3, 1, 3. Query is currently in play. And if the number of excess queries or possible excess queries is greater than the actual excess, then they're not all pure excess. Some of them are required. Some of them are required. So you're gonna make which one required? You're gonna make the longest lasting one required. You're gonna say that let's say this is index 3 is being applied here, but also there's like a 1, 3 and a 1, 9. And if you say that one of these two is going to be required, you would prefer to keep the longer lasting one. So you'd say that 1, 9 sticks around, 1, 3 is excess. Would you say that right now? You see that there's more excess than actual queries. So if you said that 1, 9 is now required, then what? Then everything between the current index and the 1, 9 has 1 less access. And then you add 1, 9 to the list of required. Yeah, that seems a lot to keep track of. Starts in excess and ends in excess. It definitely can be removed. Maybe I just keep track of things that are required and base it off of that information. So if I don't ever detect something's required, I say that it's excess. That's an interesting idea. So I'd don't try to figure out that 1, 2 is kind of totally free. I just like let it pass and not really ever add one to the list of required queries instead of required queries. But because I see that 1, 3 and 1, 9 are in a portion where there's only one access, then I make the one that's longer lasting required. Okay, I think maybe that might work. Okay, let me go ahead and just comment this thing out. Okay, so for each index in range n, so say there hmm, so for each index in range n, how am I looking through how am I passing through all these values? I'm looking at the current access. So access is going to be the access decrement at this index. I need another Q index. And I think I could probably do okay. There needs to be at some point, I just need to remind myself that I need to have something like while Q index is in the list of required indices, then Q index plus increments. There has to be, at some point I need to do that. So otherwise, my query index is at some query that is maybe applicable. So my access, if my access is 0, then I can move on. I think. I'm not sure about this. I'll say this is probably okay. If access is equal to 0, then move on to something that is not 0 for access. Probably. While the Q index is required, keep on going. Okay, so now I'm at something where my access is non-zero and I'm at the index in the queries that is not required. So for instance, connect this bot and the index is 1 and the access is 3. So I think I need to count the number of queries that can be applied to this bot. I think. So, and then I need to track stuff. So count, I'll say this thing if, well, while Q index guess this thing probably is inside the while loop actually. This while QIndex is less than n and QIndex, the query, called queries or query? Queries. And the queries at this QIndex, the start of it is less than or equal to this index, then I need to parse through it. So eventually I'll need QIndex plus equals 1. And I think here I say if QIndex is not required, then I need to do something here. If it's not required, then it's possibly access. I think count should increment by 1. I need to keep track of the endings for it, I think. Like the start can be whatever, but the endings matter. So technically, because I do this every single time, I guess I don't do this every single time because it skips over certain excess values. Maybe it skips over a bunch of zeros. Because in theory I could no, it's like a double pointer. I don't think I can skip over this. Whatever. Okay. QIndex, if the start is less than this index, if the QIndex is not required, I think maybe I need an endings. Endings.pen queries at QIndex. So what does that mean? So that means that when I see that there's 3 queries so I see that so I'm at index 1. The excess is non-zero. Every query that starts at index 1, starts at or before index 1, I'm going to add that. Starts at or before, actually, I think it might need to say if the end is before this current ending spot, right? Queries. I don't know when this would actually trigger. It might never trigger, but the query's ending is before this, or actually, yeah, the query's ending is after this spot, greater than or equal to this index. I'm not sure if if statement is necessary. Okay, so index 1 has 1, 2, 1, 3, 1, 9 as starting and ending before and after this current index. So I add it to some endings list. Add the endings to the ending list. if it's not in required count plus equals 1. Yes, maybe the count. Yes, maybe the count is not strictly necessary. Most it's the same as the length of the endings currently. Okay, so that means I go here, go here, go here. Okay, and then what? The first thing is detecting maybe when I can free up certain things as being accessed. Actually, again, I don't need to detect that. I can just let 1, 2 be 1, 2 and let it go. I feel like endings should maybe be a queue or a deck, double-ended queue. Because I don't want to pop out some endings when it's no longer applied. So so what here? So I added 1, 2, 3, 9 into the endings. Okay, so that's fine. Do I need to do anything after this loop? Probably, but let's go on. So then it goes to the next index. Index is 2. There's nothing. There's no queries that start at 2. And then it goes to the next index. Do I need to figure out that I can now remove 1, 2 as a possible access query? I think it just goes on to the next index. Okay, so then it goes on to index 3. Okay. Yeah, so the number of things that the number of access endings. So I think I do want the endings to be a double-ended queue. I append the endings that are in play, and I also pop out the endings that are no longer in state. So while endings at 0 is a ending that is smaller than the current index, endings.pop left. That removes the front of the queue. So actually, endings could be empty. So while endings, and this just makes sure that there's something in the array or in the deck. Okay, so now after I added and subtracted from the endings, I think I can compare the size of currently applicable queries and the excess. So if the excess is less than the currently applicable endings, so excess is less than the length of endings, which is the current queries in play, then I need to add those queries. I start by adding the longest lasting one. So how do I track that? I track that possibly by appending a tuple where it's the query index ending and the actual index of the query. And then if endings zeros, tuples first element is that. And then I check if the excess, then endings dot, let's say the ending and the q index is endings dot pop, or yep, just pop, and required adds this index. Okay, so at that point, so for instance, it's like does 1, 3, it does the index 1, it does the index 2, and then at the start of index 3, it removes 1, 2, basically, because 1, 2 is no longer applied to index 3. So the endings at that point is going to be 3 and 9. And so the size of the excess, which is 1, is smaller than the number of endings. So that means that some of these is required. Not all of these can be accessed. So I choose the ending that's 9 at index whatever. When I choose the ending that's 9, I need to track. I need to track that, I think. Because let's say if this was like 1, 3, and this was actually 1, 4, right? And the excess is here as well. Actually at that point, it would be like that. Yeah, it would be like that actually. So even though it's would have been counted as excess on a later index, it's no longer considered excess in this pass. Okay, actually, that might be it. Okay. And then I basically return the number of queries minus the length of the stuff that's required. Okay. 8 out of 824 cases passed, or 7 out of 824 cases passed. Okay, so 0, 3. Let's see how this one plays. Oh, did I add that wrong answer? Okay, I did. So queries is 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 1, 3. Lots of duplicates. The decrement change 5, -2, and -3. Why would there be negatives? Oh boy, what's going on here? So 0, 0. So you can increase. Okay, yeah. So you can remove 5 and 3 from the first and the second indices, and so you have basically 5 excess. Yeah, you have 5 things that are. You have 5 indices or queries that are accessed for the first index and none for the second. So technically you should be able to remove 2. Ooh, you should be able to remove 2. What did I try to remove? I guess I tried to remove everything, huh? Try to remove all 5 indices. Print the required. Print out nothing? That's odd. Required indices is empty. For every index in range n, the access is 0. If the q index at n and oh, you should definitely try to remove index q index 0 and 1. The access is 0. Oh no. Okay, so access should be 3. If the q index is less than n, which it is, and queries at the index is less than or equal to I think I see. No, I don't see it. I don't see it at all. So let's go and just dive deeper here. So the first pass, there's nothing required. In the second pass, there's nothing required. We should be able to print got here once, okay. So it does check that there's 0 excess at index 1 pretty much. So while the q index is less than n, and the queries at the q index at 0, so the start of the query is smaller than or equal to this index, so it should be going through these. if the query's ending is greater than or equal to this index, add it. Why does it keep on going? So I got here, and then let's go ahead and do checking queries at this key index. It's only checking the first two. Why is it not checking third, fourth, and fifth? The start is before this index. Index is 1. Q index of 0 should be 0. Q index of 0 should be 0. So okay, so what's going on? Sorted queries. The queries at this Q index at 1 is greater than the index. So it's not. So it's either n. N is the number of numbers. This should be Q index compared to Q. And this almost certainly should be Q index compared to Q. Okay, that was kind of silly. Silly. And I'm not surprised that that only passed 7 test cases before getting that issue. $579. Okay. Simple enough inputs. So let's go ahead and print out stuff again. Let me go ahead and reorder it so it looks more logical. Okay, so the excess is 1 at 1 and 1 at 2. So sorted, it's 0, 1, 0, 1, 1, 1, 1, 1. Okay. Okay, so what does this mean? I think I see, maybe. So how is this going to play out with what I wrote? So it's going to say that because that there is, so it looks at one excess and looks at the fact that there's two, looks at the fact that there's two things there. It's going to say one of them is not, well, it's going to say anything. roughly, so currently so there's two queries, one of which is excess. And excess is less than the number of queue endings. What is the logic there? Would excess ever be more than the number of queue endings? If excess is less than length, so if excess is equal to length of endings, then that's fine. If excess is less than length of endings, then one of them is going to be necessary. You pick the longest one. So you remove one. So let's say when I do this, so print print making an access required. I'll say QIndex and maybe the ending of the ending and the QIndex. Okay, so it's making 1 1 required. It's not making 0 1 required. Oh yeah, okay, index 1 whose ending is 1 required. Okay, that's fine. And then 0 1 is removed. No, then what? Oh, I think this is an issue of me never looking at the ending. Me never looking at the last index. Yeah, because it only detects something's not required after the ending is gone. So I wonder if I can just I wonder if I can just let me go ahead and just print out what I think is an issue here. So print out at the very end what is in my endings queue, endings deck. Interesting. 1 1 1 0 and 1 2. I thought there would just be one element in this thing. Ending at 1, index 0, ending at 1, index 2. What the heck? Queries should be shorted. Queries should be. Why is 1 0 still here? That would be like okay, now I guess 0 1 0 1 is added, and then 0 1 was removed, and then 1 1 is added, 1 1 is added. Okay, so when 1 1 is added, so the excess should be 3, and access should equal actually, yeah, I'm not sure why 1, 3 is being removed. Because on the second pass, the access should be 3. Okay, on the second pass, the access is 1. Okay, I'm screwing up the logic of this thing somehow. It's so at index 2, I think that there's a total of 1 access, and if I think that there's a total of 1 access, when I removed this thing from the list of access endings, then 0 through 1 no longer applies. It lowers the excess. What am I thinking here? So the length of the number of endings that are in play at some given index, it's not quite correct as to the number of access. Interesting. So I remove 0, 1 from the endings. That leaves the first 0, 1. And then I go to the next index, I add these two, add those two, and I see that my access is 1. So actually, shouldn't this be while loop? While access is greater than, wouldn't I pop off more than 1? Yeah, I think this should be while, right? Because if it's yeah, gosh, what is going on? It should be saying that there's 0 access here. No, if there's 0 access here, then that just means there's 0 access. Alright, what's my code doing? My code is making 1, 1 access on the first pass. So let's go and say print pass index. Alright, on the first pass where the excess is 1, sees 2 queries being applied to it. And because the number of queries is more than the number of excess, it's going to treat the second one as being required and the first one as being kind of the later one is being excess. No, later one is being required. So in that case, my excess is just this one, my excess endings. And then it goes to the next one. It's going to add these 2 queries. So there's 3 endings. And then it sees that, sees that 1 is necessary, and there's 3 endings. And so, because it's an if statement, it makes one of them, even though in theory, you probably thought it should be a while loop. And because, man, making the required, what should it have done? Making this thing 0, 1 should have made this the only thing that was removed. So if you remove, so technically you could either remove a 1, 1 or a 0, 1 in this thing, but you couldn't remove more than that. So once I made 0, 1 required, should I have modified the excess array? Yeah, because once I made it required, it's almost like I removed it from once I made it required, so when I made something required, I made the rest of it be excess, and so the rest of it should have been removed. So what does that mean? So I require a longer one. So it's like, what was that one example? So it's like 3, 3, 1. And this is like 1, 2, 1, 3, 1, 3, and I made this one 9. Okay, let's say 3, 3, 1, 1. So the 1, 2 went away. Now, each of those things, the excess is equal to the number of queries. And then it reached this point where the excess is only 1. And there's 2 queries that are in play. two queries that are in play. So I'm going to say that the longer query is required. So 1.9 is said to be required. So, but what does that mean? So 0, 1, 2, 4. 1.9 is said to be required. What if it's like a bunch of ones right there, right? So 1.4 and 1.9 are both necessary here. I think it means that every index between then and 1.9 has one less excess. Is that right? One less excess, so it's like 0 excess. If it's 0 excess, then all indices will become required. That doesn't seem right. If you have more endings, if your excess is less than the number of endings, your excess is less than the number of endings, which would be the case for every single one of those spots. 1.4.1.9. So you go through the first two excess matches, and then there's only one excess, two queries. So one of them has to. Is it ever the case that your excess is more than your number of queries? Your excess is more than the number of queries? Probably not. Probably not. I guess if you had something where, let's say it was like just 0, 2s, the queries were 0, 2, 0, 2, 0, 2, your values were 1, 1, 1, then your excess is 2, 2, 2. In that case, start the very first one. You say that one of these queries is actually now required, and your number of queries is 2 at that point. And the later ones, your queries equals your excess. So that's fine. One, 4. So you're removing 1 through 4, removing 1 through 9. You remove, so definitely want to be removing the earliest. Now you won't be treating the earliest ending one as excess. And you want to be removing the longest lasting one. and saying that's required. When you remove the longest lasting one and saying that's required, you're saying that that's required. Are you modifying your access? How should this go? So when you move this query and say that's required, you're saying that 0, 1 is still an access. So you have one access. And then you add 2 more. So you add 2 more queries at index 2, and you have 3 things. And in theory, 4 things that apply to that index. Where only one of the 4 things is technically access. Access. So I'm really screwing this thing up pretty badly in terms of like my logic here is like super long. Logic here is super long. Still passes a lot of cases when it's super wrong, but it's very wrong. Like I'm going in the wrong direction in terms of like the differences between access versus the length of queries, I think. Because it's not even closing the gap. It's not like off by 1. Like feels like it's off by 3. Like the access index 1 is actually 1, and the length of the queries is 3 at that point. The length of the endings is 3. So what does that imply? If your number of queries that extend past this index 1, so 1, 9, so my endings is 4 and 9, and index 3, I see that there's 1 excess. So that means that there's 2 queries that are decrementing this value. Kinda right now. There's 2 queries that are decrementing this value at the moment. Whereas I only need 1 query that's decrementing it. So is it the difference between the So if I remove 9, then in theory that means that 1, 4 is going to apply to this thing only, and that's pure excess. Okay, so and let's say the excess. So the values are 1, 3. Queries is 0, 1, 0, 1, 1, 1, 1, 1. The excess is 2, no, it's 1, 1. And the total decrement is 2, 4. So goes at index 1. The endings would be for 0, 1, and 0, 1. Sees that the number of queries applied to the first index is in excess by 1. So it would remove 0, 1 from the list of queries. So it's going to say that that's required. And this other 0, 1 is excess. And because it's required, then what? Then in theory, there's one less access row. In theory, yeah, this should become 0, 0. But just the later ones become 0. But if the later one becomes 0, then they're all required. The later one becomes 0, then they're all required. So in theory, this one's required and this one's required. But then what happens to this one? So if I say this one is required, then technically access is 0. Access is 0, and when I have access is 0, then I skip over it. When I have access is 0, I skip over. Okay. Well, normally when it's 0. So when I skip that stuff, then what happens? If the endings, yeah, this thing will eventually come into play. The ending is just if the endings start is the ending's end is before this index. Okay. So I need to keep track of where the endings are and modify the excess by that amount. Okay, so I think I could possibly do this using another deck. possibly use another deck for that. WQ. And that's going to be like the stuff that, the new stuff that's required. Seems a little, say this is going to be removed. And I want to add something to the required list. Then I'm going to say this is removed. Add this index. Really don't know. I don't care about the index. I just care about this ending. So this ending. I add this ending, and then I check for excess. It's excess minus the current. So while removed and removed 0 is less than this index, remove dot pop left. So this gets rid of stuff that is not in play. If excess minus the stuff that is currently in play that affects this index root, so remove dot length, is 0. So I'm not modifying the excess later on, but I am tracking whether or not some removed stuff is affecting it. So when I put on the removed, yeah, so it goes up to the index it affects. Okay. Oh, this is append. Ugh, unfortunate. Going also in the wrong direction. Output is 3. So making an excess required. Removed appends this ending. It's 1. Ooh. Well, it's not. Oh. No. So the length of the thing minus the length of the stuff that's required. So the stuff that's required is 1. Length is 4. 4 minus 1 is 3. Oh, shucks. Okay. Yeah, so okay. So what's I'm always confusing my removed versus my required, I think. So if I say that this thing is required, then I go to the next one, where the next one's axis is 1. excess is 1, but I already removed 1, so now the excess is 0. So now the excess is 0. In which case the stuff that remains is required, but not all that remains is required. Maybe it's the other way around that I should be looking at. I should be looking at the stuff that I can think of as freely accessed. So whenever I see the removed is greater than the number of queries is greater than whenever I see the number of queries is greater than the excess, then I treat the shortest query, the earliest ending query, as purely access. Treat as purely access. And then if I treat it as purely access, then I leave the other 0, 1 there, and leave the 1, 1 there, leave the 1, 1 there. And I say that the 0, 1 is excess. No, I say the earliest ending one is to be removed. So when I say that that thing is to be removed, and it's no longer considered access. Oh, yeah, I should be removing the shortest one, not the longest one. So if I remove the shortest one, which is the same in this case, but logically it makes more sense for me to remove the shortest one as being required. Or if I have a list of things that I want to remove, the list of things I want to remove is 1, everything that's required, 2, the shortest excess ones, So when I remove the shortest excess one, then the spots that it is affecting should lower in their excess. So the 1 spot becomes 0 as excess. And at that point, when I come across the 1 spot, then the queries that it affects become required. Yeah, so I remove 0, 1, the short one. But when I say I remove it, it's not means that I require it. It means that I treat it as removed excess. But is that not the same as requiring the other stuff? If I treat the shortest one as excess? I guess the difference might be the fact that the way that I calculate excess, I remove stuff from the excess at that point. When I remove stuff from the excess, it changes the excess. And it changes down to 0, and then certain things become required. And then I can either return the number of removed stuff or the stuff that is the number of removed stuff. Yeah. Turn the number of removed stuff. So there's the required, there's the removed, that is not required. They're almost complementary, but not necessarily. I'm not going to necessarily keep track of everything. So I'll just keep track of the stuff that I remove from being pure access. If I keep track of things that are removed, then the remove endings that are currently applicable reduce the access. Remove things that currently applicable reduce the access. Okay. So how is this going to play out? So I should have a set of things that I'm going to remove. Let's say removed is an actual set, and then removed endings is the deck, the DQ. Okay, so while the remove endings is there, and the first remove endings is before this, I wonder if I should be popping left and also increment it. I guess I don't need to know where I guess maybe this is just the answer to the remove count. When I pop off an ending, the answer is incremented by 1. And then if the access is greater than the access minus the remove endings is equal to 0, and then I keep on going. Access minus removed endings that are currently affecting the current index. And then how do I know when? So this is going to return the length of the removed endings, or return the answer basically. So what happens when I go through a portion where it's something like this, where the number of access matches the number of so this is going to be bigger. It's going to be bigger. Actually, I guess the one that I'm concerned with is the axis is like, let's say, 2, like 3, 3, 3, 1. Queries is 1, 2, 1, 3, 1, 3. So it's going to say access matches the number of queries for the first 2. And then it goes to this spot. And 1, 2 should have been recognized as pure access. So the number of access is equal to the number of queries. And if it ever pops off, then it should be treated as pure access. So when does it pop off? Can I use it when it pops off? If the ending of the guess this count is what I'm using. What is this count doing? If the count, the Q index is not required. I don't know if I'm using this count. So it's not required. And then I add it, and so I add the ending. And then I pop left here. Pop left here, and I maybe increment the answer here. So what do I want to do? What if at any given point, if there's anything, any given point, if there's 0 access, then I treat whatever indices that are currently applying to be required. Treat every indices that's currently applying to be required. And if at any point where an indice that I add at any given point, treat the indices that I have to be required. If there's zero excess. But then okay, so on the first pass, I found the excess indices that had zero excess, and from those I had, okay, maybe required is just a word that I'm confused. I'll say the keep. So indices of queries that apply to spots with no excess must be kept. So for every index, there's zero excess. Then indices that apply to that index must be kept. Okay, so there's the stuff that I'm keeping, and the stuff that I'm removing. So stuff that applies to zero excess indices, I keep. And then what? So then I do a second pass, going over the same indices and the same query indices. And if the current access is 0, no. If so, in theory, I should be able to determine in the second pass, looking at just the indices, just at the queries that are kept, so queries that are not in the keep. Let's go and replace that with keep. That's not one. So on the second pass, queries that are not in the keep So I keep 0, 2, and I keep 0, 2. Right. So is it the case that my access is still 3 for the second index? So because I keep 0, 2, and because I keep 0, 2, I think so. So my keep does not affect my access, right? So I'm keeping 0 to 2. So that means that my access, which was originally 0, 3, 3, 1, if I keep one of the things that's subtracting it, I still have 3 things that are strictly not necessarily to be kept at those spots. What if it was something like, what if my nums was, say, 2, 2, 3, 3, 2, 2, 3, 3, and my queries was 0, 2, 0, 2, 0, 2, 0, 2, 3, 3, 0, 4, 3, 3. So excess there is going to be excess there is going to be 1, 1, 1, no, 2, 1. No, this doesn't even work. Okay. 2. So total definite is 3, 3, 4, 1. So excess in this one is just 1. So should have figured out that 1, 4 is required to be kept. 1, 4, if 0, 4 is required to be kept, my excess is still 0, 2, 0, 2, 3, 3. Oh, my excess is still that. Okay. So on the second pass, so keep is going to be 0, 4. So on the next pass, look at the first index, index 0. I see that 0, 2 applies. 0, 4 I skip over because it's already part of the keep. So so technically what is going on here? So if I keep 0, 4, if I keep 0, 4, this is actually something I don't think anything is getting correct. Nums is 2, 2, 3, 1. Queries is 0, 2, 0, 2, 0, 4, 3, 3. My code is not even know if it's working. Queries can consist of only values from 0, 3. What the heck? Uh, 0, 4. Queries can consist the value from 0, 3. Oh, whoops. Okay. 2, 0, 4, 2, 2, 3, 9, 6 is 0. How my code does anything correct at the moment? It's probably just guessing. Okay. Total change is 2, 3, 3, 3, 2, 1. 3, 3, 3, 3, 3, 2, 1. Sure. The excess is 1, 0, 1, 1. Okay, so index is 0, there's 2, no, there's 3. Index 1, there's 3. Index 2, there's 3. Index 3, there's all 4. Index 3, there's just 2. And index 4, there's just 1. And then subtracting those, you get 1, 1, 1, 1, 0, 1, 1. Actually, let's go and make this 1, 1, 0, 1, 0. Whoops. Did I not change that correctly? Oh. Let's see, I made the nums be, this is 2, 3, 1, 1, 2, 1, yeah. So the required indices should be 0, 1, and 2. Huh. 3. Okay, yeah, I guess that's fine. I guess what I really want is to change this 0 to 1, so I'm going to make the nums at that spot be 2. So the nums at the third spot be 2. Okay, so 0, 4 is required now, which is index 2. So if 0, 4 is required, then what's going to happen? On the first pass, queries is going to be 0, 2, 0, 2. It's going to skip 0, 4 because that's part of the indices that are required equipped. So at the end of that pass, it sees that the number of excess is 1 and the number of queries that are being applied here is 2. So it's going to treat the shorter of the two as being excess, and the longer of the two as being, it's going to try to remove the shorter of the two. When it removes the shorter two, then the excess in the spots where it applies should be decremented by 1. So this thing is going to decrement this thing by 1, 1, 1. And so when it goes through these later spots, and the excess is actually now 0, then it should be keeping these other queries. But when it keeps the other queries, let's say it's keeping something that ends in like 20 here. Let's say 0, 2, 0, 20, and for the time being just ignore the 4. So it's keeping the 0, 20. It needs to mark that it's kept 0, 20 from being ever removed again. So if I want to play around with remove, play around with keep, technically play around with both. When the number of queries exceeds the excess, remove from the queries that are applied here by the shorter than. Remove the queries that are applied here by the shorter than. Alright, I think this is all jumbled up from my previous code, so I'm going to go ahead and start fresh from here. So, yeah, for index in range n, let's say there's some excess at that index. And let's say if the excess is 0, it doesn't matter. So what do I do before? While Q index, so there should be a Q index. While Q index is less than the number of queries, and Q index so query index, the start of the query index is after. Right. It's less than or equal to the current index. So say so that's the start of the index of the Q index, query index. The start of the query is before this index, and if the Q index is if it's in keep, then you're not going to do anything, right? If it's in keep, then Q index plus equals 1, and continue. Otherwise, eventually you will increase the Q index anyways. So here the Q index is not in the stuff that we keep. So then what? So the excess is 1. Our query indices that we keep are just 2. So we're at index 0, and it is the Q index that we keep, and its start is 4 after this index. Then we want to track how it extends. So okay, so active query, active queue is going to be a depth. There, I think I said active queries that we have at this index is going to be appended with the ending of this index. This Q index and the ending of it. Different than before. I think I had reversed before, but I think it's going to be fine. And then we move on. Is there anything more that I did? Nope. Yep. Okay, so here, after that loop, we have some number of active queries at the index, and we have the total excess. And if there's more queries that are active, if there's more queries that are active than the excess, we're going to treat the shortest one as being removed. So that the excess queries equals the number of active queries. So I think in theory this could be multiple, so I think there should be a while loop. When would it occur that there's going to be multiple things? When would it occur that there's going to be multiple things? Should it always just be one off? Okay. While the length of the the excess is less than the length of the active queries. And this can there be more? Then keep the, or remove the shortest active query and technically keep the rest. Okay. So remove the shortest active query. When I remove the shortest active query, then the excess should change for all the indices that the active query go to. So if there's like a, say, 0, 2, 0, 20, and 0, 200, and one of those is excess, or let's say 2 of those is excess. So let's say the excess is just 1. There's 3, no. If the excess is just 1, then I should only have 1 query. And the excess is 2, then I should have 2 queries. Okay, so let's say that the excess there was 1, then I need to remove queries from the active queries. Oh boy. That probably doesn't work as I want. Because if the excess is 1 and there's 3 queries that are active, then I could remove the 0, 2 and remove the 0, 20. So if the excess is like 1 some stuff, 1, 1, 1, 1, points. Queries is 0, 0, 2, 0, 20, and 0, 200. And the active queries at the first index is going to be 0, 2, 0, 20, 0, 200. And look at my excess. I say my excess is 1, so I only really need 1 active. So I would try to remove 0, 2, and 0, 20. But then when I try to remove 0, 2, and 0, 20, then in theory, I could be removing something that is actually required later on. Like for instance, if this is now 2 here, then when I remove the 0, 2 and the 0, 20 on the very first pass, then the number of actives in the second index is only going to be 1 and the excess is 2. So in theory, I need to have kept both 0, 20 and 0, 200. I guess this is why I did the other way around, where I did the keep rather than the remove. So if the excess is 1, then then I say if the axis is 1 and I keep, I want to say that I'm going to keep the 0, 200. And I'm going to say I'm going to keep 0, 200. How does that affect layer excess? If I keep the 0, 200, then when 0, 200 gets added to the keep, zero, 2 and 0, 20 remain active. Would the excess change? No. So keep the 0, 200. Then the excess increases in those places. No. The excess should decrease in those places. So it should become so keep 0, 200, then excess becomes 0, 1. The excess should go down in the places where the active, or the stuff that I kept, the new stuff that I kept. Here the active is now 0, 2, 0, 20. And so I go to the next one. I see that there's one excess and 2 actives. And then what? I can see that there's 1 excess and 2 actives. Then one of them should be extra. So I'm going to keep the 0, 20 at that point. Alright. I think I need to take a break. This is a head bang to a wall and it's slowly bleeding out.